Hello student, now we'll start the first chapter from the 11th standard Mathematics 2 complex number. I will explain all the concept in a very simple language and all the examples from the exercise 1.1. Already I had uploaded this exercise in my previous video, but now in in a new frame, and I hope that you will enjoy this video and you will understand all the concept whatever that I am explaining here. Now let us start. Complex numbers. Let's learn. In this chapter you will learn the complex number, algebra of complex number, geometrical representation of complex number, polar and exponential form of complex number, Cn for it is a short form, complex number, De Moivre's theorem. Now the introduction. Consider the equation x square plus 1 is equals to 0. This equation has no solution in set of real numbers. It means that there is no real number whose square is a minus 1. Because there is no real number whose square is minus 1. We need to extend the set of real numbers to a larger set, which would include solutions of such equations. Okay, that will include the solutions of this type of the equations. Now next we introduce a symbol I, that is a Greek letter iota, which such that I square is equals to minus 1 or I is equals to root of minus 1. And I square is equals to minus 1. I is called an imaginary unit or an imaginary number. Swiss mathematician Leonhard Euler was the first mathematician to introduce the symbol I with I is equals to root of minus 1 and I square is equals to minus 1. Now see this here, a complex number, imaginary number, a number of the form bi, where b belongs to set of real number and b is not equals to 0. I is equals to root of minus 1 is called an imaginary number. Example, a root of minus 25, the square root of a root of 25 is a 5, but here 25 into minus 1, that is minus 1 means what? Root of minus 1 means what? I. Therefore, if we take the square root of 25 is 5 and root of minus 1 is I, and therefore root of minus 25 is equals to 5i. Next is a 2i, 2 by 7i minus 11i, etc. Note that the number I satisfies following properties. I into 0 is 0. If a belongs to set of real number, then a root of minus a square is equals to I square into root of I square into a square. And if you take the square root, then you will get plus or minus IA. Minus a square means what? Minus 1 into a square, and minus 1 means what? I square. And if you take their square root, then you will get plus or minus IA. Next, if a comma b belongs to set of real number and ai is equals to bi, then a is equals to b. A complex number, that is the definition, a number of the form a plus ib, where a comma b belongs to set of real number and I is equals to root of minus 1, with I square is equals to minus 1, is called a complex number, and it is denoted by z. That is, z is equals to a plus ib, where a comma b belongs to set of real number and I is equals to root of minus 1. Here a is called the real part of z and it is denoted by real part of z, that is rz, and b is called imaginary part of z and it is denoted by imaginary part of z or iz. The set of complex numbers is denoted by capital C, just like the set of real number is denoted by the capital R. Set of whole number is denoted by the W. In this way, the complex number is denoted by the capital C. That is, C is equals to a plus ib, such that a comma b belongs to set of real number and I is equals to root of minus 1. Now see this here, the table, that is a z complex number. It is of the form a plus ib. And what is the real part and what is the imaginary part? The first is 2 plus 4i. The complex number in this form, a plus ib, is a 2 plus 4i. Real part is 2, imaginary part is 4. 5i. And now in this case, it is written as 0 plus 5i. Therefore, real part is not there. Therefore, we write here 0 plus 5i. Real part is 0, imaginary part is 5. 3 minus 4i. And in this case, 3 minus 4i. Real part is 3, imaginary part is minus 4. 5 plus root of minus 16. And root of minus 16 can be written as 4i. That is, the square root of 16 is 4. And square root of minus 1, that is 16 into minus 1. Square root of that minus 1 is I. Therefore, real part is 5 and imaginary part is 4. Next is a 2 plus root 5i. And in this case, the real part is 2 and imaginary part is root 5. 7 plus root 3, and in this case, 7 plus root 3, this is the real part and imaginary part is a 0i. Therefore, real part is a 7 plus root 3 and the real part is imaginary part is 0. Next is note that a complex number whose real part is 0 is called purely imaginary number. Such a number is of the form z is equals to 0 plus ib is equals to ib. Second, a complex number whose imaginary part is 0 is a real number. That is, z is equals to a plus I 0i. That is equals to a, which is the real number. Next, a complex number whose both real and imaginary parts are 0 is the 0 complex number, that is the 0 is equals to 0 plus 0I. The set of R of the real number is a subset of set of complex number, that is the R is a subset of C. The real part and the imaginary part cannot be combined to form a single term. For example, 2 plus 3i, we cannot add this. 2 plus 3i is not equals to 5i. We cannot add this. Now the algebra of complex number. Equality of two complex numbers. The first is definition. Two complex numbers z1 is equals to a plus ib and z2 is equals to c plus id are said to be equal if their corresponding real and imaginary parts are equal. That is, a plus ib is equals to c plus id if a is equals to c and b is equals to d. First example, if x plus iy is equals to 4 plus 3i, then x is equals to 4 and y is equals to 3. Next, if 7a is equals to I in bracket 3a minus b is equals to 21 minus 3i, then find a and b. It's very simple. Equate the real and imaginary part. Now here we will equate it. That is 7a is equals to 21 by equating the real and imaginary part. Okay. Therefore 7a is equals to 21. Therefore a is equals to 3. A is equals to 21 upon 7. Therefore a is equals to 3. Now substitute the value of, that is equating the imaginary part. To the left hand side, imaginary part is 3a minus b, and to the right hand side, imaginary part is minus 3. Therefore 3a minus b is equals to minus 3. Substitute the value of, I will repeat again here, 7a is equals to 21. Therefore a is equals to 3. 3a minus b is equals to minus 3. Therefore 3a, this minus 3 to the left hand side and minus b to the right hand side. Therefore it will become 3 into 3 plus 3 is equals to b, and therefore b is equals to 12. Therefore b is equals to 12. Next is definition of conjugate of complex number. That is, if the z is equals to a plus ib is defined as a minus ib, that is, it's a conjugate of z is equals to a plus ib is a minus ib. That we change only the sign of the imaginary part. If it is a plus, then write it as a minus. If it is a minus, then write it as a plus. Now here the conjugate of this z is a minus ib, and it is denoted by z bar. Next, see this here table, 3 plus 4i, then its conjugate is a 3 minus 4i. Change the sign of only imaginary part. If it is a plus, then it is a minus. Next is a 7i minus 2. The sign of the imaginary part is plus, right here minus. Minus 7i minus 2. 3 and 3. Keep it as it is because 3 is a real number. 5i and its conjugate is a minus 5i. 2 plus root 3. It is again as it is. 7 plus root 5i. Change the sign. 7 minus root 5i. Next is properties of conjugate, that is a z bar. See this here. Conjugate of conjugate, that is the original number. If we take the complex number, Find out its conjugate, and again the conjugate of conjugate, then it is the original number, original complex number. If the z is equals to z bar, then z is a purely real number. It's clear that z is equals to minus z bar, then z is a purely imaginary. Now we define the four fundamental operations of addition, subtraction, multiplication, and division of complex numbers one by one. Addition of complex numbers. Let z1 is equals to a plus ib and z2 is equals to c plus id. Then z1 plus z2 is equals to a plus ib plus second bracket c plus id. Then z1 plus z2 is equals to a plus c, and in the second bracket b plus d. Take the r as a common, and therefore z1 plus z2 is equals to in first bracket a plus c plus in second bracket b plus d bracket complete into r. In other words, real part of z1 plus z2 is equals to real part of z1 plus real part of z2, and imaginary part of z1 plus z2 is equals to imaginary part of z1 plus imaginary part of z2. Next, properties of addition. If z1, z2, z3 are complex numbers, then z1 plus z2 is equals to z2 plus z1. That is the property of commutative. Next, z1 plus in bracket z2 plus z3 is equals to z1 plus z2 in first bracket and then plus z3. It is associative. Third is z1 plus 0 is equals to 0 plus z1, and that is equals to z1, which is the identity. Now z plus z bar is equals to 2 times real part of z. You can verify it. Now in bracket z1 plus z2 bar is equals to z1 bar plus z2 bar. Examples. If the z is equals to 7 plus 3i, then 5z is equals to, that is 5 in bracket 7 plus 3i. Their multiplication, 35 plus 15i. Next example. z1 is equals to 3 minus 4i and z2 is equals to 10 minus 9i. Then 2 times z1 plus 5 times z2 is equals to 2 in bracket 3 minus 4i plus 5 in bracket 10 minus 9i. That is 6 minus 8i plus 50 minus 45i. 2 times z1 plus 5z2 is equals to their addition. 6 plus 50, 56 minus 8 minus 45. That is 53i. Next example, subtraction. Subtraction of complex number. Let z1 is equals to a plus ib and z2 is equals to c plus id. Then define z1 minus z2. That is z1 plus in bracket minus 1 into z2. A plus ib plus in bracket minus 1 in bracket c plus id. Therefore add this. A plus ib minus c minus id. Therefore z1 plus z2. Sorry, z1 minus z2 is equals to a minus c. This is the first one. And what about the second? ib minus id. Take I as a common from these two terms, ib and minus id. Then in bracket you will get b minus d. Now the real part of z1 minus z2 is equals to real part of z1 minus real part of z2. It's clear. Imaginary part of z1 minus z2 is equals to imaginary part of z1 minus imaginary part of z2. Now the example. See this example. Z1 is equals to 4 plus 3i and Z2 is equals to 2 plus I. Z1 minus Z2 is equals to, in bracket 4 plus 3i, that is the first complex number, minus 2 plus I. Now 4 minus 2 in first bracket, in second bracket 3 minus 1, bracket complete into I. 4 minus 2, it means 2. 3 minus 1, that is a 2. Therefore Z1 minus Z2 is equals to 2 plus 2i. Z1 is equals to 7 plus I, Z2 is equals to 4i, Z3 is equals to minus 3 plus 2i. Then find out 2 times Z1 minus 5 times, in bracket minus 5 times Z2 plus 2 times Z3. Now substitute the values of Z1, Z2 and Z3. Then you will get the answer. That is the 2 times Z1 means 7 plus I minus 5 in bracket Z2, which is the 4i, plus 2 in bracket minus 3 plus 2i. Simplify this. Then you will get 14. 2 into I, that is a 2i, minus, simplify this. 5 into 4, that is a 20i, minus 6. And next is a 4i. Again simplification. 14 plus 2i. Next is a 20i plus 20i plus 4i, that is a 24i and minus 6. Now open this bracket. Then you will get minus 6 will become plus, and plus 24 will become minus 24i. And therefore after the simplification, 14 plus 6, that is a 20. 2i minus 24i. Then you will get minus 22i. Multiplication of complex number. Let Z1 is equals to A plus IB and Z2 is equals to C plus ID. We denote the multiplication of Z1 and Z2 as Z1 into Z2 and is given by Z1 into Z2 is equals to A plus IB, bracket complete, C plus ID. And their multiplication, that is A will multiply to this whole bracket and IB will multiply to this whole bracket. Then you will get AC. And next is a ADI. This is ADI. Next is the BIC. Next is a BI into DI. That is the I square BD. But what is I square? I square is a minus 1. Therefore, this is the AC. ADI plus BCI. Take I as a common. Then you will get minus BD. And here, that is a Z1 into Z2 is equals to AC minus BD plus AD plus BC, bracket complete into I. This is the multiplication of the complex number. Next is first example. Z1 is equals to 2 plus 3i and Z2 is equals to 3 minus 2i. Then Z1 into Z2 is equals to 2 plus 3i, bracket complete, 3 minus 2i. They are normal multiplication. That is a 2 into this whole bracket, 3i into this whole bracket. Then you will get 6 minus 4i. And next is a 9i minus 6i square. See this here. First is 6 minus 4i. Next is 3i into 3, that is a 9i, and 3i into minus 2i, that is a minus 6i square. But I square is a minus 1, that is a 6 minus 4i plus 9i, I square is minus 1, therefore it will become plus 6 only. Now 6 plus 6, that is a 12, minus 4i plus 9i, it will become 5i. See this here. Therefore Z1 into Z2 is equals to 6 plus 6 is 12. 9i minus 4i, that is will become 5i. Next example. Z1 is equals to 2 minus 7i, Z2 is equals to 4 minus 3i and Z3 is equals to 1 plus I. Then 2Z1 in first bracket into second bracket Z2 dot Z3 is equals to 2 in bracket 2 minus 7i dot 4 minus 3i into again 1 plus I. Now we will simplify this. Substitute their values. That is a 2 into Z1. That is a 2 into 2, 4. 2 into 7. That is a 49. Next, the multiplication of this bracket. 4 into 1. That is a 4. 4 into I. 4I. 3I minus 3I into 1. Minus 3I. Minus 3I into I. Minus 3I square. Next is a 4 minus 49. Now simplify this. I square is minus 1. Minus 3 into minus 1, that is a 3. 3 plus 4, 7. And 4i minus 3i, that is a I. Next multiplication, that is a 4 into 7, 28. 4 into I, 4i, minus 49 into 7, minus 98i. And minus 49 into minus I, minus 49 square. Now here, I square is again minus 1. 14 into minus 1, that is a 14. Therefore, 28 plus 14, it is a 42. And next is a plus 9 plus 4i minus 98i. Then you will get minus 94i. And therefore, 2 times z1 into z2 is into z3 is equals to 42 minus 94i. Now the properties of multiplication. First is z1 into z2 is equals to z2 into z2, z2 into z1, this is a commutative. Next is a z1 into z2 in first bracket into z3, and that's equals to z1 into in second bracket z2 into z3, that is associative. Next is a z1 into 1, that is equals to 1 into z1, and that is equals to z1, which is the identity. That is 1 is the identity element for the multiplication and 0 is the identity element for the addition. Next is a z1 into z2, where conjugate is equals to z1 bar into z2 bar. If z is equals to a plus ib, okay, z is equals to a plus ib, then z dot z bar, that is nothing but a square plus b square. You can verify this. That is, z is equals to a plus ib and z bar is equals to a minus ib, and their product a square minus I square b square. I square is minus 1, and therefore overall you will get a square plus b square. Powers of I. We have root of minus 1 is I square is minus 1. I cube is, now this is the I cube, and it can be written as I into I square, but the value of I square is minus 1. Minus 1 into I, which is a minus I. What about the I raised to 4? I square is minus 1 and it's a square. Minus 1 square is a plus 1, therefore I raised to 4 is 1. Okay, I raised to 4 means what? I square and whole bracket square. But I square is minus 1 and it's a minus 1 square means what? It's a plus 1. Therefore it is a plus 1. I cube means what? I into I square. But what is I square is minus 1. Minus 1 into I. It's a minus I. Let us consider the I raised to n, where n is a positive integer and n is a greater than 4. We divide n by 4 and obtain the remainder r. Let m be the quotient. Then n is equals to 4m plus r, and the value of r must lie between 0 to 4 and not 4. Therefore, I raised to n is equals to I raised to 4m plus r. That is nothing but I raised to 4m into I raised to r. I raised to 4m can be written as I raised to 4. Bracket complete, bracket raised to m. The value of I raised to 4 is 1. Here is 1. And 1 raised to m means what? 1. I raised to r, and you will get the result I raised to r. And therefore, whenever you have the big number, that n is equals to, n is a big number, and therefore it is written as n is equals to 4m plus r. Then it's a direct value is I raised to n is nothing but I raised to r. Similarly, I raised to 4m is equals to 1, and that is equals to 1 upon I raised to 4m, and that is equals to I raised to minus 4m. I square is minus 1. I cube is I into I square. I square is minus 1. Minus 1 into I is minus I. I raised to minus 1 can be written as 1 upon I. Multiplied n and d by I. 1 into I is I into I is I square. I square is minus 1, and overall you will get minus I. Next is the I raised to 50, and this is the I raised to 4, and whole bracket is to 12. Okay, that is a 12 into 4. It's a 48 into I square. But what about this? This is the 1. 1 into I square. This is I square. I square is minus 1. Next is I raised to 318. That is I raised to 4, and whole bracket is to 79. But the value of this whole bracket is 1. 1 into I square. I square is minus 1, and overall you will get minus 1. Next is I raised to 999. And again it can be written as, divide this number by 4. Then you will get I raised to 4. The quotient is 249. The remainder is 3. But the value of this I raised to 4 and whole bracket is to 249. This is the 1. 1 into I cube. But I cube is minus I. That is therefore the overall the value is a minus I. Now the remark. In general, I raised to 4n is 1. I raised to 4n plus 1 is I. I raised to 4n plus 2 is a minus 1. I raised to 4n plus 3 is a minus I, where n belongs to z. You can remember this also. Now the division of complex numbers. The first is, let z1 is equals to a plus ib and z2 is equals to c plus id be any two complex numbers such that z2 is not equals to 0. Now z1 upon z2, that is equals to a plus ib upon c plus id, where z2 is not equals to 0, that is a c plus id is not equals to 0. Multiply and divide by conjugate of z2. Therefore, z1 upon z2 is equals to a plus ib, c plus id into the conjugate of c plus id is a c minus id multiplied nd by c minus id. Now what is a c plus id into c minus id? That is a c square plus d square. That is a c square minus I square d square, but I square is minus 1, and therefore overall it will become c square plus d square. See this here. A plus ib into c minus id. Now see this here multiplication. It's very simple. That's multiplication. You can perform that multiplication also. And here is the c square plus d square. Separate it AC plus BD upon c square plus d square plus BC minus AD upon c square plus d square bracket complete into R. Therefore, AC plus BD upon c square plus d square belongs to set of real number, and BC minus AD upon c square plus d square belongs to set of real number. Next is illustration. If the z1 is equals to 3 plus 2i and z2 is equals to 1 plus I, then z1 upon z2 is equals to 3 plus 2i upon 1 plus I. Now their simplification. Multiply numerator and the denominator by the conjugate of 1 plus I, which is the 1 minus I. Therefore, z1 upon z2 is equals to 3 plus 2i upon 1 plus I into 1 minus I upon 1 minus I. Therefore, their multiplication 3 into 1 3, 3 into minus I is a minus 3i, 2i into 1 is a 2i, 2i into minus I minus 2i square, 1 plus I and into 1 minus I, that is a 1 square plus minus I square, but I square is minus 1, minus 1, I square is a minus 1, but I and therefore that minus and minus will become plus. Therefore here is a 1 plus 1, and then we'll simplify this. That is a 3 plus minus 2i square. I square is a minus 1, and that is minus and minus will become plus. Here you will get 2 plus 3, that is a 5, minus 3i plus 2i, then you will get minus I. Therefore z1 upon z2 is equals to 5 upon 2 minus 1 upon 2i. Now next is properties of division. 1 upon I is equals to 1 upon I. Multiply numerator and denominator again I upon I. Then you will get this I into I is a I square, which is its value is a minus 1. Therefore 1 into I is I upon minus 1, and overall you will get minus I, and therefore 1 upon I is minus I. Next is 1 upon A plus IB, then multiplied, it's a conjugate to the numerator and denominator. Then you will get 1 into A minus IB, and if you multiply this number 1 plus IB by its a conjugate, then you will get A plus IB into, in next bracket, A minus IB, and their multiplication is nothing but the A square plus B square. Now let us start the exercise. Simplify. First, root of minus 16 plus 3 root of minus 25 plus root of minus 36 minus root of minus 625. Solution. Root of minus 16 plus 3 root of minus 25 plus root of minus 36 minus root of 625. Now it's 16 can be, minus 16 can be 16 into minus 1 plus 3 minus 25 into minus 1 minus 36 into minus 1 and minus 625 into, that is 625 into minus 1. Here must be bracket. Okay, I must have written here bracket must be here. Okay, next is a square root of 16 is a 4 root of minus 1, 3 into 5 root of minus 1, 6 into root of minus 1 minus 25 into root of minus 1, that is you will get 4i, 15i, next is a 6i minus 25i. Therefore overall you will get 4i plus 15i plus 6i minus 25i. Therefore 4 plus 15 plus 6 minus 25 bracket complete into I, and overall that is equals to 0. That is 4 plus 6 10 plus 15 25 plus 25 minus 25, that will become 0. Therefore the answer is next is 4 into root of minus 4 plus 5 into root of minus 9 minus 3 into root of minus 16. Again the simplification. 4 into root of minus 4 plus 5 into root of minus 9 minus 3 into root of minus 16. Again it is written as 4 into minus 1, 5 in root of 9 into root of 9 into minus 1, 3 into in root of 16 into minus 1. Therefore again the square root of this 4 is 2, this 4 is as it is. Root of minus 1, next is the square root of this 9 is 3, 5 into 3 15. Again the square root of this 16 is 4, and next is their simplification, 8i plus 15i minus 12i, and overall you will get 8 plus 15 minus 12i, and their simplification is 11i. Therefore we can write the answer in this manner. Write the conjugates of the following complex numbers. 3 plus I. The conjugate is a 3 minus I. Change the sign of only imaginary part. The conjugate of 3 minus I. It's a 3 plus I. Conjugates of 3 minus I is a 3 plus I. Third is a minus root 5 minus root 7I. Its a conjugate is a minus root 5 plus root 7I. Minus in bracket minus root 5. It's a solution. The conjugates of minus in bracket minus root 5, that is a minus root 5I, which is the root 5I. Now the conjugate is a root 5I. Okay. Next is a 5I minus 5I. Next example. It's very simple examples. Again the conjugate of root of 5 minus I, root of 5 plus I. Change the sign of only the imaginary part. Next example, 2 plus root 2 plus root 3I. That is a root 2 plus root 3I. Its a conjugate is a root 2 minus root 3I. Next is a cos of theta plus I times sin theta. Therefore again the conjugate of cos theta plus I times sin theta is a cos theta minus I times sin theta. Change the sign of the imaginary part. Find A and B if first is A plus 2B plus 2AI is equals to 4 plus 6I. Solution. A plus 2B plus 2AI is equals to 4 plus 6I. Equating the real and imaginary part. Separately, then we get A plus 2B is equals to 4 and 2AI is equals to 6. 2A is equals to 6. 2AI is equals to 6I, therefore 2A is equals to 6. A is equals to 3. Substitute the value of A here, then you will get that is a 3 plus 2B is equals to 4. 2B is equals to 3. 4 minus 3 is 1. Therefore B is equals to 1 upon 2 and hence A is equals to 3 and B is equals to 1 upon 2. Second one, A minus B in first bracket plus second bracket A plus B bracket completed into I is equals to A plus 5I. Now the solution, A minus B plus A plus B bracket complete I is equals to A plus 5I. Now again the equating the real and imaginary part. What is the real part here? A minus B and here is A. Therefore we get here A minus B is equals to A and A plus B is equals to 5. Now here B is equals to 0. As B is equals to 0, substitute the value of B, that is A plus B is equals to 5. B is 0, therefore you will get A is equals to 5. Okay, A is equals to 5 and hence the answer is A is 5 and B is 0. Next is A plus B in first bracket, second bracket 2 plus I is equals to B plus 1 plus 10 plus 2AI. Now first of all we want to simplify this. In first bracket A plus B, second bracket 2 plus I is equals to B plus 1 plus 10 plus 2A bracket complete I. Their simplification, A plus B into 2. Next is A plus B into I. Next is B plus 1. 10 plus 2A bracket complete into I. That is a 2A plus 2B plus A plus B bracket complete into I. b plus 1 plus in next bracket 10 plus 2a bracket completed into I. Okay, equating the real and imaginary part. We get 2a plus 2b is equals to b plus 1 and a plus b is equals to 10 plus 2a. Now simplify this. 2a plus 2b minus b is equals to 1 and a plus b minus 2b is equals to 10. After the simplification, you will get 2a plus b is equals to 1 and minus a plus b is equals to 10. Subtracting a minus a plus b is equals to 10 from 2a plus b is equals to 1. Then you will get, after simplification, see this here, change the sign, bb will get cancelled. See this here, 2a plus a, that is a 3a, and 1 minus 10, it's a minus 9. Therefore, a is equals to minus 3. Substituting a is equals to minus 3 in minus a plus b is equals to 10. We get minus in bracket minus 3 plus b is equals to 10. Minus and minus will become plus, therefore b is equals to 10 minus 3, which is 7, and hence the answer is minus 3 and a is minus 3 and b is 7. Next is ABI is equals to 2a minus b plus 12i. Again the simplification, ABI is equals to 3a minus b plus 12i. Equating again the real part and imaginary part. From the left hand side there is no real part. Therefore we treat as a 0. 0 plus ABI is equals to 3a minus b plus 12i. That is a 0 plus ABI is equals to 3a minus b plus 12i. That is a 3a minus b is equals to 0 and 12i is equals to ABI. Therefore, we get 3a minus b is equals to 0 and AB is equals to 12. 3a minus b is equals to 0. Therefore, b is equals to 3a. Substituting the value, that is b is equals to 3a in AB is equals to 12. Then we get a into in bracket 3a is equals to 12. That is 3a square is equals to 12. A square is equals to 4. A is equals to plus or minus 2. When a is equals to 2, then b is equals to 3 into a. That is 3 into 2, which is 6. And when a is equals to minus 2, then b is equals to 3 into a. That is 3 into minus 2 is equals to minus 6. Hence, a is a plus or minus 2 and b is a plus or minus 6. Next is 1 upon a plus ib is equals to 3 minus 2i. Now the simplification, 1 upon a plus ib is equals to 3 minus 2i. Therefore, a plus ib is equals to, if we simplify this, 1 upon a plus by ib will invert into, if we apply here, then you will get a plus ib is equals to 1 upon 3 minus 2i. Now multiply this term by it's a conjugate part, and divide the conjugate of 3 minus 2i, which is 3 plus 2i. Then a plus ib is equals to 1 upon 3 minus 2i multiplied 3 plus 2i upon 3 plus 2i. Then you will get a plus ib is equals to 3 plus 2i, 9 minus 4i square. That is it. Okay. Therefore, you will get 9 plus 4, 13. Therefore, a plus ib is equals to 3 upon 13 plus 2 upon 13i. Equating real and imaginary part. We get a is equals to 3 by 13 and b is equals to 2 upon 13. Next is in bracket, first bracket a plus ib, second bracket 1 plus I is equals to 2 plus I. Solution: a plus ib in second bracket 1 plus I is equals to 2 plus I. And simplify this. A plus ib is equals to 2 plus I upon 1 plus I. Now multiply again the conjugate of 1 plus I. The conjugate of 1 plus I is 1 minus I to the numerator and the denominator. That we want to simplify it. See this here. After their multiplication, therefore here you will get I square is a minus 1, minus and this minus and that will become plus 1. Minus 2i plus 1, it's a minus I. 2 plus 1, that will become 3. I square is again minus 1. Minus and again minus, that will become plus. 1 plus 1 is 2. Therefore, a plus ib is equals to 3 minus I upon 2 is equals to 3 upon 2. Separate it, minus 1 upon 2 I. Therefore, equating the real and imaginary part, we get a is equals to 3 by 2 and b is equals to minus 3 by 2. You can also see this, the previous one. See this here. This is the previous one. Next is that we have clear here. Next is express the following in the form a plus ib, where a comma b belongs to set of real number and I is equals to root of minus 1. State the values of a and b. Now I will again repeat this. Express the following in the form a plus ib, where a comma b belongs to set of real number and I is equals to root of minus 1. State the values of a and b. The first is 1 plus 2i in first bracket, second bracket minus 2 plus I. Now their simplification, that is a 1 into minus 2 is a minus 2, 1 into I is I. 2i into minus 2, that is a minus 4i. 2i into I, that is a 2i square. I square is again minus 1. Minus 1 into this 2 is a minus 2. Next is a minus 4i plus I, that is a minus 3i. Minus 2, minus 3i, minus 2. And overall you will get minus 4, minus 3i. And there ends the answer. Minus 4, minus 3i. This is of the form a plus ib, where a is equals to minus 4 and b is equals to minus 3. Now the next is second one. In first bracket 1 plus I, in second bracket 1 minus I bracket is 2 minus 1. Now we'll simplify this. See this here, 1 plus I, 1 minus I bracket is 2 minus 1. And this power is minus 1. Therefore, it is a 1 plus I upon 1 minus I. Now multiply the conjugate of this denominator, which is 1 plus I. Its the conjugate is 1 plus I. And their multiplication, 1 plus I bracket square. And to the denominator, when we multiplied with its conjugate, that is a square plus b square, means not 1 square plus 1 square. And then here you will get 1 plus I bracket square. And next is a 1 minus I square. Its a square is a 1 plus 2i plus I square. 1 minus I square. Next is 1 plus 2i minus I. Plus 1 minus 1 get cancelled. 1 plus 1 is 2. I square is minus 1. Therefore 2i upon 2, you will get I. Therefore 0 plus I. Therefore 1 in first bracket 1 plus I, second bracket 1 minus I, bracket is 2 minus 1 is equals to 0 plus I, and therefore here is a real part A is 0 and imaginary part B is 1. Okay, next is I in bracket 4 plus 3I upon 1 minus I. Solution. I in bracket 4 plus 3I upon 1 minus I. 4I plus 3I square. 1 minus I. That is a 4I. I square is minus 1 minus 3. 1 minus I. 4I minus 3 multiplied with its conjugate. Then we let 4I minus 3 into 1 plus I. And 1 minus I into 1 plus I. That is a 1 minus I square. Now the multiplication of 4I minus 3I into 1 plus I is a 4I square minus 3 minus 3I, and their simplification. 4I minus 3 minus 4I minus 4 minus 3 minus 3I upon 1 plus 1, and their simplification. Minus 4 and minus 3 minus 7. 4I minus 3I is I, and separate it. Therefore here again it is of the form A plus IB, where A is equals to minus 7 by 2 and B is 1 upon 2. Next is 2 plus I upon in bracket 3 minus I into 1 plus 2I. Solution. Their multiplication. That is 3 into 1 is 3. 3 into 2I is a 6I. Minus I into 2I is a minus 2I square, and minus 1 into I is a minus I. Next is 2 plus I. Here is a 2I square. I square is minus 1. That minus and minus will become plus. That is a 3 plus 2. And here is a 6I minus I, 5I. Therefore 2 plus I upon 5 plus 5I multiplied with its conjugate. This here. Their multiplication. You will get 10 minus 5I plus 5 upon 25 plus 25. That is 15 minus 5I upon 50 plus 15 upon 50 minus 5 upon 50I, and their simplification. That is a 3 upon 10 minus 1 upon 10I. Okay. Next is this is of the form A plus IB, where A is equals to 3 upon 10 and B is equals to minus 1 upon 10. In bracket 1 plus I upon 1 minus I bracket square. Now their simplification first of all. 1 plus I bracket square upon 1 minus I bracket square. Expand this. 1 plus 2I plus I square, 1 minus 2I plus I square. I square is minus 1. And that's why you will get here. Overall, it is a minus 1. And only the real part is there. Minus 1 can be written as minus 1 plus 0I. And this is of the form A plus BI, where A is equals to minus 1, B is 0. Next is a 3 plus 2I upon 3 minus 5I plus 3 minus 2I upon 2 plus 5I. It's a solution. Cross multiplication. 3 plus 2I into 3 plus 5I plus 3 minus 2I into 2 minus 5I. This is the cross multiplication upon 2 minus 5I into 2 plus 5I. Their multiplication, you can simplify this also. Okay. I square is again minus 1, and minus that will become plus 1. Now the addition 6. Here is a 10 square is a minus 1, again plus 6, and the next is a 10 into minus 1, again this is the, okay. Now plus 4i minus 4i get cancelled, minus 15i plus 15i get cancelled, and overall you will get, that is a minus 8 upon 29. You can simplify this. Here is a minus 20 and plus 12, that is a minus 8, and this is the 25 plus 4, which is the 29, and the imaginary part is 0 here, and the real part is a minus 8 upon 29. Next is a 1 plus I bracket is to minus 3. It's a solution. 1 plus I bracket is to minus 3. 1 upon 1 plus I bracket is to 3. Again, their simplification. A plus B bracket cube. That is a cube plus 3a square b plus 3ab square plus b cube. In the same manner. That is 1 upon 1. 1 cube is 1. 3 into 1 square into this I. Next is a 3 into 1 into I square and plus I cube. And their simplification. See this here. That is the 1 upon 1 plus 3i. I square is minus 1 minus 3. I cube is minus I. Here is equal to sign. Next is a simplification. 1 plus 1 minus 3 minus 2. 3i minus I plus 2i. Okay. Multiplied with its conjugate. And then you will get. Okay, I square is minus 1, minus and minus, that will become plus 4 plus 4, that is 8. After simplification, 2 upon 8 is minus 1 by 4, minus 1 by 4i. And this is of the form a plus ib, where a is equals to minus 1 by 4 and b is equals to also minus 1 by 4. Now 2 plus in root of minus 3 upon 4 plus in root of minus 3. Convert this in the complex number. This, that is a 2 plus root 3 root of minus 3 upon 4 plus root of minus 3. That is a 2 plus root 3i upon 4 plus root 3i multiplied with the conjugate of this denominator, which is 4 minus root 3i. Then here you will get their multiplication. 2 into 4 is 8. 2 into minus root 3i is a minus 2 root 3i. Next is a root 3i into 4, that is a 4 root 3i. Root 3i into minus root 3i, that is a minus, and root 3 into root 3, that will become 3i into I square. And to the denominator, that is a plus b, a minus b, a square minus b square. Here is a 8 and 3i square is minus 1. And that minus and minus will become plus. 3 plus 8 is 11. Next is a minus 2 root 3i plus 4 root 3i. Then you will get 2 root 3i. 16 plus 3, that is a 19. And therefore 11 upon 19 plus 2 root 3i upon 19. Therefore again this is of the form a plus ib, where a is equals to 11 upon 19 and b is equals to 2 root 3 upon 19. Next is a minus root 5 plus 2 root of minus 4 plus 1 minus root of minus 9 plus 2 in first bracket 2 plus 3i into 2 minus 3i. First we will simplify this. Okay. Minus root 5, 2 minus 2 into root of minus 4, 1 minus. Now this is the minus root 5 plus 2 into root of minus 4 plus 1 minus root of minus 9, and the product of these two bracket, in first bracket 2 plus 3i into second bracket 2 minus 3i. Their simplification, see this here, that is a 2, the square root of 4 is 2, 2 into 2 4, and root of minus 1 is I. Next is again 1. Root of minus 9 is a 3i again. Next is the multiplication of this a plus b, a minus b. That is a 2 square means 4 minus 3i bracket square means what? 9i square. And their simplification. We can convert this. You can see this. Next is a minus root 5 plus 4i. 1 minus 3i, 4. Minus 9i square, I square is minus 1. And that minus and minus will become plus. Therefore, it is a plus 9. Now collect the real numbers. That is a 14 minus root 5. That is a 9 plus 4. 13 plus 1. 14. And this is a minus root 5. What about the I? 4i minus 3i. It is I. This is of the form a plus ib, where a is equals to 14 minus root 5 and b is 1. Next is 2 plus 3i into 2 minus 3i. It's a purely real number. That is a 2 plus 3i into 2 minus 3i, and that's equals to 4 minus 9i square. That is the I square is minus 1. Again minus and minus will become plus. 4 plus 9, that is a 13. 13 plus 0i. This is of the form a plus bi, where a is a 13 and b is a 0. Now the next is a 4 I raised to 8 minus 9 I raised to 9 plus 3 upon 3 into I raised to 11 minus 4 into I raised to 10 minus 2. I raised to 8 means what? I square, and it's a bracket raised to 4. I square is minus 1. Minus 1 bracket raised to 4 means what? 1. Next is I raised to 9. Can be written I raised to 8 into I. But I raised to 8 is 1. Okay, we have already done here. 1 into I, that is I. I raised to 11. I raised to 11 can be written I raised to 10 into I. I raised to 10 means what? I square and bracket raised to 5 into this I. I square is minus 1. Minus 1 raised to 5 is a minus 1. Minus 1 into I is a minus I. Next is I raised to 10. I raised to 10 can be written as I square bracket raised to 5. And that is equals to minus 1 bracket raised to 5. Overall you will get minus 1. Now substitute all these values. That is 4 into 1 minus 3i plus 3. The value of I raised to 11 is a minus I. Value of I raised to 10 is minus 1. And last is minus 2. And then simplify. 4 minus 3i plus 3. To the numerator minus 3 plus 4 minus 2. And 4 plus 3, that is a 7 minus 3i to the numerator. And denominator 2 minus 3i multiplied with its conjugate. Then you will get here their multiplication 7 minus 3i into 2 plus 3i. 14 plus 21i minus 6i minus 9i square. 4 minus 9i square. I square is minus 1. 14 plus 15i plus 9. 4 plus 9. I square is a minus 1. 14 plus 9, that is a 23 plus 15i upon 13. 23 upon 13 and 15 upon 13i. This is of the form a plus ib, where a is equals to 23 upon 13 and b is equals to 15 upon 13. Show that minus 1 plus root 3i bracket cube is a real number. It's a solution. Now we'll expand by using the formula. A plus b bracket raised to 3. That is the first term cube plus 3 into first term square into second term plus 3 into first term into second term square plus second term cube minus 1, and here is a plus 1. 3 into root 3i. Next is a minus 3. Root 3i square means what? 3i square. And last is a root 3i bracket cube means what? Root 3 into root 3i into root 3i into root 3i. Root 3 into root 3 is a 3. 3 root 3 I cube. Next is a minus 1. plus root 3i, 3i square. I square is minus 1. And this minus and minus will become plus. 3 into 3, 9. And last is I cube means what? I cube means what? Minus I. Substitute the value. Then here you will get minus 3 root 3i. I cube means what? Minus I. And therefore it will become minus root 3i. This plus and minus will get cancelled. Minus 1 plus 9, 8. And which is the real number. Next is find the value of, in bracket, first bracket, 3 plus 2 upon I. Second bracket, I raised to 6 minus I raised to 7. Bracket complete. Plus in the last bracket, 1 plus I raised to 11. Solution. I raised to 6 means what? I square bracket cube. I square is minus 1. Minus 1 raised to 3 is minus 1. I raised to 7 means what? I raised to 6 into I. I square bracket cube into I. Minus 1 raised to 3 into I, which is minus I. I raised to 11. I raised to 10 into I. I raised to 10 can be I square bracket is to 5 into I. Overall minus 1 raised to 5 into I, and you will get minus I. Therefore, the 3 plus 2 upon I raised to 6 minus I raised to 7, and in the last bracket, that is 1 plus I raised to 11. This equals to 3 plus 2 upon I raised to 6. What is I raised to 6? I raised to 6 is minus 1. I raised to 7. I raised to 7 is a minus I. And this minus and minus will become plus. Therefore, it is a plus I. What about the last bracket? 1 plus I. What is I raised to 11? I raised to 11 is a minus I, which is 1 minus I. Now simplify this again. That is a minus 3 plus 2 minus in bracket 3 plus 2 upon I, 1 minus I into again 1 minus I. And here the bracket square, 1 minus I bracket square. Their simplification. 3 plus 2 upon I, 1 minus I bracket square. That is 1 minus 2I plus I square. I square is minus 1. Plus 1 and minus 1 get cancelled. Here you will get their multiplication, minus 6i, and again their multiplication 2 upon I into minus 2i. I get cancelled, you will get minus and minus, that will become plus. Therefore it is a 4, 6i plus 4, 4 plus 6i. In first bracket 2 plus 3 plus 2 upon I, second bracket I raised to 6 minus I raised to 7. Next bracket 1 plus I raised to 11, that is equals to 4 plus 6i. Evaluate the following. I raised to 35. I raised to 35 can be written as I raised to 34 into I. That is I square bracket is to 17 into I. I square is minus 1 bracket is to 17 into I. And that is a minus 1 into I. Minus 1 raised to 17 means what? Minus 1. Minus 1 into I. Next is I raised to 35 is equals to minus I. I raised to 888. Therefore, again, this can be written as I raised to 888. I square and bracket is to 444. I square is minus 1. And minus 1 raised to 444. That is a plus 1. Next is a I raised to 93. It can be written as I raised to 93 is I raised to 92 into I. I square and bracket is to 46 into I. Minus 1 raised to 46 into I. Which is again 1 into I is I. Next is a I raised to 116. Again, it can be written as I raised to 116. I square and bracket is to 58. I square is minus 1. Minus 1 is to 58. That is a plus 1. Next is a I raised to 403. I raised to 403. is equals to I raised to 402 into I. I square bracket is to 201 into I. I square is minus 1 raised to 201 into I, which is minus 1 into I, and that is a minus I. Next is a 1 upon I raised to 58. Again their simplification. I raised to 58 can be written as I square and bracket raised to 29. I square is minus 1 raised to 29. Then you will get again minus 1. 1 upon minus 1, overall it is a minus 1. Here is the answer. 1 upon I raised to 58 is minus 1. Next is a I raised to minus 888. It can be written as 1 upon I raised to 888. I square and bracket is to 444. I square is minus 1 and minus 1 is to 444. That is a plus 1. Therefore answer is 1. Next is a I raised to 30 plus I raised to 40 plus I raised to 50 plus I raised to 60. I raised to 30 plus I raised to 40 plus I raised to 50 plus I raised to 60. That is can be written as I raised to 30. I square bracket is to 15. I square bracket is to 20. I square bracket is to 25. I square bracket is to 30. Minus 1 is to 15. Minus 1 is to 20. Minus 1 is to 25. Minus 1 is to 30. Overall minus 1 plus 1 minus 1 plus 1. And the answer is 0. Therefore, we write the answer in this manner. Next is question number 8. Show that 1 plus I raised to 10 plus I raised to 20 plus I raised to 30 is a real number. Okay. See this here. We'll simplify this. It's normal, simple example. I raised to 10 can be written I square bracket is to 5. I square bracket is to 10 plus I square bracket is to 15. I square is minus 1 bracket is to 5. Minus 1 is to 10. Minus 1 is to 15. And you will get 1 minus I plus 1 minus 1. And overall you will get 0, which is the real number. Next is a question number 9. Find the value of. The first is I raised to 49, I raised to 68, I raised to 89, I raised to 110. Same type of examples are here. I raised to 49 plus I raised to 68 plus I raised to 89 plus I raised to 110. I raised to 48 into I raised to 68 plus I raised to 89 into I plus I raised to 110. I raised to 48 means what? I square bracket is to 24 into I. I square I raised to 68 means what? I square bracket is to 34 plus I square bracket is to 44 into I. I square bracket is to 55. Here I square is minus 1 raised to 24 into I, minus 1 raised to 34, minus 1 raised to 44 into I, and minus 1 raised to 55. Overall you will get I plus 1, next is a I, and last is a minus 1. Plus 1 minus 1 get cancelled, I plus I is a 2I. Okay, next is a second one, I plus I square plus I cube plus I raised to 4. Here is a I plus I square plus I cube plus I raised to 4. I plus I square plus I cube can be written as I square into I. I raised to 4 can be I square and bracket square. I square is minus 1. I square is minus 1 into I. Minus 1 bracket square. I minus 1 minus I plus 1. and plus I minus I get cancelled, plus 1 minus 1 get cancelled, and overall you will get 0. Next is question number 10. Solve I raised to 592, I raised to 590, I raised to 588, I raised to 586, I raised to 584 upon I raised to 582 plus I raised to 580 plus I raised to 578 plus I raised to 576 plus I raised to 574. Find the value. It's very simple. Again, we'll write this example here. Now, first of all, we take the common I raised to 584, which is less one in the numerator, the power which is less, I raised to 584. Take I raised to 584 as a common. Then in bracket you will get I raised to 8, then I raised to 6, then I raised to 4, I square and 1. In the same case, for the denominator, which is less power, I raised to 574. Take I raised to 574 as a common. Then in bracket you will get I raised to 8, I raised to 6, I square and 1. And now, what is in bracket? These two terms are same, therefore we can cancel it. I raised to 584 upon I raised to 574. Now we can simplify. That is I raised to 10 by using the law of indices. 584 minus 574. Then you will get I raised to 10. I raised to 10 can be written as I square bracket is to 5. I square is minus 1 bracket is 5, which is the plus 1. Minus 1, sorry. Minus 1 raised to 5 means what? Minus 1. It's a minus 1. Next is a example number 11. Find the value of 1 plus I square plus I raised to 4 plus I raised to 6 plus I raised to 8 up to dash dash I raised to 20. Now the solution. See, this is a very interesting example. First is 1 I square plus I raised to 4, I raised to 6 plus I raised to 8, I raised to 10 plus I raised to 12, I raised to 14 plus I raised to 16, I raised to 18 plus I raised to 20. See this here 1 I square. What is here? I square and bracket square. I square bracket cube. I square bracket is to 4. I square bracket is to 5. I square bracket is to 6. Next is I square bracket is to 7. I square bracket is to 8. And next is I square bracket is to 9. I square bracket is to 10. Substitute the value. I square is minus 1. Minus 1 raised to 2 means what? Plus 1 here. And here is a minus 1. Minus 1 and plus 1 get cancelled. Next, in a similar manner, I square is a minus 1. Minus 1 cube means what? Minus 1. And minus 1 raised to 4 is the plus 1. Again, this term will get cancelled. In a similar way, all the terms, all these bracket will get cancelled. See this here. Minus 1 square means what? Plus 1. Plus 1 minus 1 get cancelled. And overall, here you will get 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1. Okay. And you will get the answer 1 plus 0 plus 0 plus 0 plus 0. The answer is 1. And hence we write the final answer as a 1. Next is a question number 12. 1 plus I raised to 10 plus I raised to 100 minus I raised to 1000, that's equals to 0. And it's very simple. See that I raised to 10 can be written I square bracket is to 5. I raised to 100 means what? I square bracket is to 50. I raised to 1000 means what? I square bracket is to 500. I square means what? Minus 1 raised to, sorry, here is a, by mistake I have taken here is a 3, but there is a 5. Okay. I square bracket raised to 50. Next is a I square means what, a minus 1 raised to 500. Overall we will get the value as a minus 1, but here must be 5. Okay, minus 1 raised to 5 means what, again minus 1. Minus 1 raised to 50 means what, plus 1. Minus 1 raised to 500, it is a plus 1, but here is a minus sign. Now again the plus 1 minus 1 get cancelled, plus 1 minus 1 get cancelled, and overall you will get 0, and hence it is RHS. Hence LHS is equals to RHS. That is the answer. Next is number 13. Is a real number. Justify your answer. I will justify. Substitute the values. See this here. 1 plus I raised to 14 plus I raised to 18 plus I raised to 22. 1 plus I square bracket raised to 7. 1 plus I square bracket raised to 9. 1 plus, that is, sorry, I square bracket raised to 11. 1 plus I square bracket raised to 7 plus I square bracket raised to 9 plus I square bracket raised to 11. I square is minus 1. Minus 1 raised to 7 is minus 1. And this is will be the minus 1, and this is a minus 1. Minus 3 plus 1. Overall you will get minus 2. See this here. Next is which is the real number, and hence it is approved. Next example, question number 40. We want to evaluate this. See this here. I raised to 37 plus 1 upon I raised to 67. If you simplify this, what is this? I raised to 67 into I raised to 37 means what? 37 plus 67. It is 104 plus 1 upon I raised to 67. But what about the I raised to 104? I square bracket raised to 52 plus 1. I raised to 67 means what? I raised to 66 into I. I square is minus 1 bracket raised to 52 plus 1. I square bracket raised to 33 into I. Next is a minus 1 raised to 52 means what? 1 plus 1 minus I square means what? Minus 1. Minus 1 raised to 33 into I. Overall you will get minus 1. See this here. Next is I will show first of all the previous example. I am to see the first previous example. Now we'll see this example again. Okay, that is here 1 plus 1. Okay, 1 plus 1 is a 2. Okay, that is a 2 upon minus 1 raised to 33. That is the overall minus 1. That is a 2 upon minus I, and then we'll evaluate it. Okay, I think that I have not completed that example, and you can complete it. Okay. See this here. I want to see this example again. Now I will show this example again. See this here. Next is that is 1 plus 1, that is a 2. Okay, what about the next? That is a 2 upon minus I. Then we will multiply it to the numerator. That is a I. Then you will get 2I, I into I, which is the I square, and that you will get the plus sign. Therefore, overall you will get 2I their answer. Okay, I have not completed it. You can complete it. Now this is the next example 15. 1 plus I bracket raised to 4 into 1 plus 1 upon I bracket raised to 4, that is equals to 16. What is again? I will repeat here. 1 plus I bracket raised to 4 into, in next bracket, 1 plus 1 upon I bracket raised to 4 is equals to 16. Now 1 plus I bracket square means what? 1 plus 2I plus I square. Next is a 1 plus 2I square is minus 1. Plus 1 and minus 1 get cancelled. That is a 2I. Next is a 1 plus I bracket is to 4. 1 plus 1 upon I bracket is to 4. 1 plus I bracket square into, if we simplify this, then you will get I plus 1 upon I bracket is to 4. See this here, 1 plus I bracket is to 4. 1 plus I bracket is to 4 upon I raised to 4. Here again the simplification, 1 plus I bracket is to 8. I raised to 4 means what? 1. That is I square and bracket is to 2. I square is minus 1, minus 1 square is a plus 1. And the next is a, again this can be written as 1 plus I bracket square and bracket is to 4. Expand this. That is 1 plus I bracket square means what? It is a 2I and bracket is to 4. If we simplify this, 1 square plus 2I plus I square is minus 1 plus 1 and minus 1 get cancelled. You will get overall 2I. Bracket is to 4. You can simplify this. Okay. 2I bracket is to 4 means what? 16. I raised to 4. I raised to 4 means what again? 1. Okay. And hence the answer is 16, which is the RHS. Next question. Hence 1 plus I raised to 1 plus I bracket is to 4 into 1 plus 1 upon I bracket is to 4, that is equals to 16. It is proved. Question number 16. It's very again simple. That I raised to 6 plus I raised to 7 plus I raised to 8 plus I raised to 9 upon I square plus I raised to 3. Take I raised to 6 common from the numerator. Then in bracket you will get 1 plus I square plus I cube upon I square in bracket 1 plus I. Again the value of this 1 plus I square is a minus 1. I cube is a minus I. Now therefore plus 1 minus 1 get cancelled. And plus I and minus I again get cancelled. Overall you will get 0 to the numerator. And therefore the answer is 0. Its value is a 0. Next problem. If a is equals to minus 1 plus root 3I upon 2 and b is equals to minus 1 minus root 3I upon 2, then show that a square is equals to b and b square is equals to a. Given that a is equals to minus 1 plus root 3I upon 2, now it's a square. Minus 1 plus root 3I upon 2 bracket square. Expand this. Minus 1 plus root 3I bracket square. Minus 1 square plus 2 into minus 1 plus root 3I plus root 3I bracket square upon 2 square. 1 minus 2 root 3I. Root 3I bracket square means what? Root 3 square means 3. I square is minus 1. 1 minus 3, which is minus 2. Minus 2 root 3I upon 4. Take the 2 as common. Then simplify. You will get minus 1 minus root 3I upon 2. That is equals to b. Okay. Now next is b is equals to minus 1 minus root 3I upon 2. It's a square. That is minus 1 minus root 3I upon 2 bracket square. Minus 1 square plus 2 times minus 1 into minus root 3I plus minus root 3I bracket square upon 2 square. 1 plus 2 root 3I minus, then minus root 3I bracket square means what? Minus 3. 1 minus 3, which is a minus 2. Okay. Minus 2 plus root 3I upon 4. Take the 2 as a common. Minus 1 plus root 3I upon 2. Simplify it. And then you will get This is nothing but the a, therefore b square is equals to a. Next example. This is the, by mistake, this is the question number 18. That is the, if x plus iy is equals to a plus bi bracket is to 3, then show that x upon a plus y upon b is equals to 4 in bracket a square minus b square. Now see this, first of all, x plus iy is equals to a plus ib bracket is to 3. Now first of all, x plus iy is equals to a plus ib bracket is to 3. Then the expansion of a plus ib bracket is to 3. A cube plus 3 a square into ib plus 3a ib bracket square plus ib bracket cube. X plus iy is equals to a cube plus 3a square bi plus 3a b square I square plus b cube I cube. Substitute the value of I square and I cube. I square is minus 1, I cube is a minus I. See this here. X plus iy is equals to a cube plus 3a square bi minus 3ab square minus b cube I cube is minus 1, minus I cube is minus I square is minus 1. Collect the terms of the real part and the imaginary part. A cube minus 3ab square plus 3a square b minus b cube bracket completed into I. Equate it. And therefore here you will get equating the real and the imaginary part separately. We get x is equals to a cube minus 3ab square and y is equals to 3a square b minus b cube. Therefore x is equals to, we'll take the a as a common, then in bracket a square minus 3b square. Y is equals to, take b as a common, in bracket 3a square minus b square. Therefore x upon a is equals to a square minus 3b square, y upon b is equals to 3a square minus b square. Now their addition. X upon a plus y upon b is equals to a square minus 3b square plus 3a square minus b square. And simplify this. X upon a plus y upon b is equals to 4a square minus 4b square. Take 4 as common. Then you will get a square minus b square. Okay. Now the next is question number 19. If a plus 3i upon 2 plus ib is equals to 1 minus I, then show that 5a minus 7b is equals to 0. That is, we will simplify this only. A plus 3i upon 2 plus ib is equals to 1 minus I. A plus 3i, make the cross multiplication, then you will get 2 plus ib into 1 minus I. Take their multiplication. That is, a 2 into 1 is 2, 2 into minus I is minus 2i, ib into 1 is bi, ib into minus I, that is a minus bi square, I square is minus 1, and overall you will get 2 minus 2i bi, this is the b. Okay, next is a plus 3i is equals to real part. Collect the terms of the real part. 2 plus, that is a b plus 2 plus b minus 2 bracket complete into I. Equating the real and the imaginary part. Separately we get a is equals to b plus 2 and 3 is equals to b minus 2. Therefore a is equals to as b plus 2. If you simplify this, then you will get 3 plus 2, which is 5. Therefore b is equals to 5. Substitute the value of b here, 5. Therefore a is equals to 5 plus 2, which is a 7. And what is the value of 5a minus 7b? Substitute the value of a, which is 7, and the value of b, that is a 5. Next is a 35 minus 35, that's equals to 0. And hence 5a minus 7b is equals to 0. Next is a number 20. If x plus iy is equals to in root of a plus ib upon c plus id. Then prove that x square plus y square bracket square is equals to a square plus b square upon c square plus d square. See this here. X plus iy is equals to in root of a plus ib upon c plus id. Squaring on both sides. X plus iy bracket square is equals to a plus ib upon c plus id. X square plus 2xy I plus y square I square multiplied with its a conjugate of the denominator c plus ib. Its a conjugate is a c minus ib. Then simplify it. X square plus 2xy I square is a minus 1. Therefore, it is a minus y square. What about here? The multiplication of a plus ib into c minus id. Okay. The multiplication of these two terms, a plus ib into c minus id, a into c, ac, a into id, that is a minus a di, bi into c, bci, bi into minus id, that is a minus bdi square, I square is a minus 1. And the next is a substitute the value of I square, that is a minus 1. Therefore, x square minus y square plus 2 xyi minus ac minus adi plus bci plus bd upon c square plus d square. A square minus y square plus 2 xyi, and that's equals to, again we collect the terms of real and the imaginary from the numerator, that ac plus bd in first bracket plus bc minus ad in second bracket into I upon c square plus d square. Separate it. X square minus y square plus 2xyi, separate it, ac plus bd upon c square plus d square plus bc minus ad upon c square plus d square into I. Equate it. Separately, x square minus y square is equals to ac plus bd upon c square plus d square. This is the real part. And next is a 2xy is equals to bc minus ad upon c square plus d square. X square plus y square bracket square is equals to x minus y square bracket square plus 4x square y square. This is the formula that you have to remember. If we expand it and equate it, the middle term is a minus 2x square y square, but we require plus 2x square y square. That's why we are adding here 4x square y square. Again, substitute the value of this x square minus y square brackets and the 2xy. Okay. And if you simplify this, then you will get ac plus bd bracket square plus bc minus ad bracket square upon c square plus d square bracket square. A square c square plus 2 abcd plus b square d square plus b square c square minus 2 abcd plus a square d square upon c square plus d square bracket square. A square c square plus b square c square plus a square d square plus b square d square upon c square plus d square bracket square. Therefore, x square plus y square bracket square is equals to a square plus b square upon c square plus d square. Hence, it is approved. Next is a question number 21. If a plus ib is equals to 1 plus I upon 1 minus I, then prove that a square plus b square is 1. Again, the simplification. Multiplied the conjugate part of 1 minus I, which is the 1 plus I, to the numerator and denominator. Then simplify. That a plus ib is equals to 1 plus I bracket square upon 1 minus I square. I square is minus 1. 1 plus 2I plus I square. 1 minus I square. I square is minus 1. 1 plus 2i minus 1. 1 plus 1 is 2. Okay. Here is a 2i upon 2, which is I. A plus ib is equals to I. A plus ib is equals to I means what? 0 plus 1i. Equate it. Here a is equals to 0 and b is equals to 1. And b is equals to 1. Next is a square plus b square. 0 square plus 1 square. Overall you will get 1. And hence a square plus b square is equals to 1. It is approved. Next example. Show that root 7 plus I root 3 upon root 7 minus I root 3 plus root 7 minus I root 3 upon root 7 plus I root 3 is real. Now the simplification. This here. Make here the cross multiplication. That is the root 7 plus I root 3. If we multiply the cross multiplication, then in bracket square, here is also bracket square upon the to the denominator multiplication of these two denominator terms. That is the root 7 minus I root 3 into root 7 plus I root 3. Expand this. A plus b bracket square. That is the root 7 square means what? 7. 2 into root 7 into I root 3. Okay. Root 7 into root 3 means what? Root of 21. And here is a I root 3 bracket square means what? I square. Root 3 square means what? 3. 3i square. Next is a root 7 minus I root 3 bracket square. This is a 7 minus 2 root of 21. Root 3 into root 7 is a root of 21 into I. And the last is a I square. Root 3 square means what? 3. Then simplify this. This is the a minus b, a plus b. A square minus b square. Now their simplification. And here is a 7 minus 3 plus 7 minus 3. 7 plus 7, 14. 14 minus 6. 7 plus 3, that is a 10. There is a 8 upon 10. 14 minus 6, that is a 8. 8 upon 10. This is the, after simplification, you will get 4 upon 5, which is the real number. Question number 23. If x plus iy bracket cube is equals to y plus vi, then show that y upon x plus v upon y is equals to 4 in bracket x square minus y square. Okay. See this here. The solution. Y plus iv is equals to x plus iy bracket cube. Expand this. X cube plus 3x square. Iy plus 3x iy bracket square plus iy bracket cube. Y plus iv x cube 3x square yi plus x y square I square plus y cube I cube. I cube means what? Minus I. Therefore y plus iv is equals to x cube 3x square yi minus I square is a minus 1 minus 3xy square. I cube means what? Minus I minus y cube I. X cube minus 3xy square plus 3x square y minus y cube. Bracket complete into I. Take I as a common from these two terms. Therefore here, equating the real and the imaginary part, we get y is equals to x cube minus 3xy square and v is equals to 3x square y minus y cube. Therefore, again, it can be as in this manner. Same thing. Take x as a common, and from this take y as a common. We required y upon x and v upon y. See this here, y upon x is equals to x square minus 3y square, and v upon y is equals to 3x square minus y square. Add it. That is y upon x plus v upon y is equals to x square minus 3y square plus 3x square minus y square. And if you simplify it, then you will get, here is a x square and 3x square, 4x square, minus 3y square, minus y square, minus 4y square. And hence, that is y upon x plus v upon y is equals to 4 in bracket x square minus y square. Hence, it is a proof. Next is question number 24. Find the values of x and y which satisfy the following equations, where x and y belongs to set of real number. The first is a x plus 2y plus x minus 3y bracket complete into y is equals to 4i, that's equals to 5. Solution: x plus 2y plus x minus 3y into I plus 4i is equals to 5. And their simplification, normal. Okay. Equating the real and imaginary part. That x plus 2y is equals to 5 and 2x minus 3y is equals to minus 4. X plus 2y is equals to 5, 2x minus 3y is equals to minus 4. Simplify it. This is equation number 1 and this is the equation number 2. That is that x plus 2y is equals to 5, x minus 3y is equals to 4 multiplied. The repetition is here, see this here. This is equation number 1. Equation number 2. Multiplied the equation 1 by 2 and we get 2x plus 4y is equals to 10. Subtract equation 2 from this equation, we get 7y is equals to 14. If we simplify it, then you will get these two are the only simple simultaneous equation. Y is equals to 2. Therefore, substitute the value of y in equation number 1. Then you will get here that x plus 2 into 2 is equals to 5. Therefore, x plus 4 is equals to 5. X is equals to 1. And hence, the solution set is that is x is equals to 1, y is equals to 2. Next, second one, x plus 1 upon 1 plus I is plus y minus 1 upon 1 minus I is equals to I. Okay. And their simplification, cross multiplication is here. In bracket x plus 1 into 1 minus I plus y minus 1 into 1 plus I upon the multiplication of these two denominator. That is 1 plus I into 1 minus I is equals to I. Multiplication. That is 1 into x is x, 1 into minus I is minus ix. 1 into 1 is 1, 1 into minus I is minus I. Y into 1 is y, y into I is yi. Minus 1 into 1 is 1, minus 1 into I is minus I. Normal simplification, 1 plus I into 1 minus I is 1 minus I square, that is equals to I. Okay. Now collect the terms of I real part and the imaginary part. X plus 1 plus y and the minus 1. This is the real part. What about the imaginary part? Xi minus I plus yi minus 2i, that is equals to I. I square is minus 1 and that minus and minus 1, that will become plus 1 is 2. And here is x plus y plus y minus x minus 2 bracket complete into 2i is equals to 2i. Again equate it, the real and imaginary part. X plus y is equals to 0 and y minus x minus 2 is equals to 2. Y minus x minus 2 is equals to 2. What's here? Y minus x is equals to 4. Next is x plus y is equals to 4. If you add these two, then you will get here, adding these two equations, x will get cancelled, you will get the value of y, that is the 2y is equals to 4, y is equals to 2. You can simplify this, you have learned in the 10th standard. Therefore, from 1, x plus 2 is equals to 0. Therefore, x is equals to minus 2. And hence, x is equals to minus 2 and y is equals to 2. Now the third example, x plus iy upon 2 plus 3i plus 2 plus I upon 3 minus 2 minus 3i is equals to 9 upon 13 bracket complete, 9 upon 13 into in bracket 1 plus I. Okay. Now again here the example, cross multiplication is here. I had written here directly the cross multiplication of x plus iy into 2 minus 3i. X into 2, that is the 2x. X into minus 3i, minus 3ix. Y, iy into 2, that is a 2iy. Iy into minus 3i, that is a minus 3y I square. And the next multiplication. Okay, that is a 2 into 2, 4. 2 into I is a 2i. Next is a 3 into 2 is a 6i. 3i into I, 3i square. Okay, upon the product of this denominator, that is in bracket 2 plus 3i into 2 minus 3i. Okay. Then again simplify this. 2x minus 3ix, 2iy. I square is minus 1. Therefore, it will become plus. This is the 3y, 4, 6i, 2i. I square is again minus 1, minus 3. Okay. Therefore, we will collect the real part. That is a 2x plus 3y plus 4 minus 3. 2x plus 3y. Okay. Here is a plus 4 minus 3 is 1. And the imaginary part, that is a minus 3ix plus 2iy plus 8i. What about the I? 6i plus 2i, 8i. 4 plus 9, 13 is equals to 9 upon 13 in bracket 1 plus I. Again, their simplification. You can see this. 2x plus 3y plus 1 plus minus 3x plus 2y plus 8 bracket complete into I is equals to 9 plus 8i. Okay. Sorry, 9 plus 9i. Now equate it, the real and imaginary part. 2x plus 3y plus 1 is equals to 9. What about the next? Minus 3x plus 2y plus 8 is equals to 9. Therefore, 2x plus 3y is equals to 8. And what about here? Minus 3x plus 2y is equals to 9 minus 8 is 1. Equation number 1. Next is minus 3x plus 2y is equals to equation number 2. Multiply in equation 1 by 3. You can simplify this 1 by 3 and 2 by 2. Then we get 6x plus 9y is equals to 24 minus 6x plus 4y is equals to 2. Adding these two equations, then you will get 9y plus 4y, that is a 13y. 24 plus 2, 26y is equals to 2. Therefore, from 1, 2x plus 3 into 2, substitute the value of y is equals to 8. 2x plus 6 is equals to 8. Therefore, 2x plus 6 is equals to 8 and 2x is equals to 2. X is equals to 1. Hence, x is equals to 1 and y is equals to 2. Next example, number 4. X in bracket 1 plus 3i plus y in bracket 2 minus I minus 5 plus I cube is equals to 0. Again, their simplification. X in bracket 1 plus 3i plus y in bracket 2 minus I minus 5 I cube is equals to 0. Normal multiplication 3 into 1, 3 into 3i, 3xi, 2 into I, 2i, y into minus I, minus yi, minus 5, I cube is a minus I, that's equals to 0. Collect the real part and the imaginary part. X plus 2i plus 3x minus y bracket complete into I, 5 plus I. Okay, equate it. X plus 2y is equals to 5 and 3x minus y is equals to 1. See this here. X plus 2y is equals to 5 and 3x minus y is equals to 1. Simplify these two equations. Equation number 1, this is equation number 2. Now we'll see this here. Multiply the equation number 2 by 2, that y will get cancelled. Then you get 6x minus 2y is equals to 2. Add the equation to first, we get 7x is equals to 7, x is equals to 1. Therefore, from 1, put the value of x is equals to 1. We get 1 plus 2y is equals to 5, 2y is equals to 4. Therefore, y is equals to 2 and hence the value of x plus y is equals to 1 plus 2 is equals to 3. Next, this is the last example. Okay. X plus 2i plus 15i raised to 6 into y is equals to 7x plus I cube in bracket y plus 4. Then find the value of x plus y. I had not written here. Now see this here, x plus 2i plus 15 I raised to 6 into y, 7x plus I cube in bracket y plus 4. Simplify it. X plus 2i as it is. I raised to 6 means what? I square and bracket raised to 3 means what? It is a minus 1. Therefore, it is a minus 15y. Okay. This is 7x. I cube means what? Minus I in bracket y plus 4. Here is the term. I raised to 6 means what? I square bracket cube. It's a minus. I square is minus 1. Minus 1 raised to 3 means what? Again minus 1. I cube, that we know. I cube means what? I square into I. I square is minus 1. And therefore, overall, it is a minus I. Again, the x plus 2i minus 15y minus 7x plus I in bracket y plus 4 is equals to 0. Collect the terms of x minus 7x minus 6x minus 15y plus 2 plus y plus 4 bracket complete I. Take I as common is equals to 0 plus 0 into I. Equate the real and imaginary part. Minus 6x minus 15y is equals to 0. Okay. Next is a 2 plus y plus 4. That is a 2 plus 4 is a 6. Y plus 6 is equals to 0. Therefore, y is equals to minus 6. Equating their real and imaginary part. Okay. Y is equals to minus 6. Put in equation number 1. And then you will get minus 6x minus 6 into minus 15, that is a plus 19. Therefore, 6x is equals to 19. And therefore, 6x is equals to minus 6x is equals to minus 19. That is a 6x is equals to 90. Therefore, x is equals to 15. And hence, x plus y is equals to, the value of x is 15 and y is a minus 6. That is a 15 minus y. That is equals to 9. Therefore, x plus y is equals to 9. And in this way, we have completed the first exercise. Now we'll see the next video. Till then, goodbye.